So 3.2 HCF, we've already looked at factors, and a factor is a number that divides evenly into another number. So a common factor of two or more numbers would be numbers that divide evenly into both of them. So if we had the numbers 8 and 10, 2 would be a common factor because they divide into both 8 and 10. And with common factors, then we also have something that's known as the highest common factor, and that would be the largest number that divides evenly into them all. There's also the lowest common factor, but it's actually pretty standard. It's actually the same for every set of numbers, and that's 1. So 1 is the smallest whole number that will divide evenly into any number and every number. So that's not very useful for us to know, because it's not a unique property, whereas the highest common factor is. So it's a lot more useful, and that's the one thing that we use in a number of different areas. So to find the highest common factor, one way to do it would be to list all the factors of each number that you have in common. You can then underline or highlight any that are in common, and then by looking through them you can see which one is the highest. So if we had the numbers 12, 15, 30 and 45, the factors of 12 are 1 and 12, 2 and 6, 3 and 4. And between 15, you've got 1 and 15, 3 and 5. And then we can see the rest for 30 and 45. So we can highlight all the ones that are common. So there's a 1 that's common to them all. And there's a 3 that's common to them all. If we were to look at just a couple of them, so if we were to look between 15 and 30, they would also share 5 and 15. Or between 30 and 45, they would also share 15 and 5. But across the four numbers, 12, 15, 30 and 45, the highest common factor is 3. So the highest common factor must be less than or equal to the smallest of the numbers. It can't be bigger than any of them, because a factor divides evenly into another number, and it's not a multiple. So try not to confuse HCF with what we're going to look at next. So 3.3, multiples and LCM. So a multiple is the opposite of a factor, and the best way to think about it is all the numbers that appear in the times tables. Now in primary school we probably learned the first 10 or 12 multiples of each number, but as we know, multiples go on for forever. So we would only ever look at a small list of these. So if we're looking at the first 6 multiples of 12, they'd be the first 6 multiples of the 12 times tables. So it'd be 12, 24, 36, 48, 60 and 72. And try not to forget about 12. So 12 is a multiple of 12. It's the first multiple of 12. So essentially to work out the multiples, you do 12 times 1, 12 times 2, 12 times 3 and so on. So the 100th multiple of 12 would be 12 multiplied by 100, which would be 1200. If we want to work out the first 5 multiples of 15, so we do 15 times 1, 15 times 2, 15 times 3, 15 times 4, and 15 times 5, which are 15, 30, 45, 60, and 75. And the list would go on. So a multiple is a number that appears in the times tables of a list. A common multiple of 2 or more numbers then would be all the numbers that appear on each times tables list. And the lowest common multiple is a unique number, and it's the first number to appear on the times tables list of each of the numbers. There is a highest common multiple, but for any sets of numbers that's infinity, so it's not very useful. But the lowest common multiple is. So if we've got these numbers 9, 12 and 18, if we write down the multiples of each, so the multiples of 9 would be 9, 18, 27, 36, 45, 54, 63, 72, 81, and 90. Multiples of 12, you'd have 12, 24, 36, 48, 60, 72, 84, 96, 108, and 120. And the multiples of 18 then, so you've got 18, 36, 54, 72, 90, 108, and so on. Now what we can do is we can highlight all the common ones. So I can see there is a 36 in all three multiples. There's also 72. And there's 108, and there would be 108 in the 9 times tables. So it would go on to 99 and 108. So what we can see, there are a number of multiples. The common multiples would be 36, 72, 108. And the lowest common multiple then is 36. So what we can see then, there are sometimes we can look for shortcuts. So 18 is a multiple of 9. So any multiple of 18 will also be a multiple of 9. So we can look through the multiples of 18 and 12 and compare those two rather than thinking necessarily about 9. And just to note, the lowest common multiple of a set of numbers must be greater than or equal to the largest of the numbers. So because it's a multiple, the key letter there is M, it's a multiple, it's going to be in the times tables list, and it could be greater than or equal to the largest number, but it has to be bigger than certainly the smaller numbers that are in the list. And just to note, don't mix up LCM and HCF. People often do get confused between them. It probably isn't helpful that one starts with the lowest and one starts with the highest, but it's the multiple and factor bit that is the giveaway. So it's the multiple and factor that we're looking for. So if you're looking for the lowest common multiple, we're looking for a number that's bigger, and if we're looking for the highest common factor, we're looking for a number that's smaller. And an example then, in 2 schools, the first bell rings at 9 a.m. The first bell rings every 35 minutes. So 9 a.m., 35 minutes. In the second school, the bell rings every 45 minutes. And the bell rang as well at 9 a.m. So at what time will the bells ring together again? Now that is going to be a longer time. It's not going to occur as a smaller number, it's going to be a bigger number. So whenever we're looking for a larger number, that's going to be the LCM. It's going to be a multiple of the two. It's not going to be a factor, so it's not going to be in a shorter amount of time, it's in a longer amount of time, so that's a multiple. So what we need to do is we need to look at the multiples of 35 and 45. So the multiples of 35, you've got 35, 70, 105, 140, 175, 210, 245, 280, 315, and 350. The multiples of 45, so we've got 45, 90, 135, 180, 225, 270, 315, 360, and so on. And looking at those lists at the minute, we can see that there is a common multiple, and that's 315. So that means after 315 minutes, the bells will be together again. So that poses another question is, well, how long is that? So we know that there are 60 minutes in an hour. And what that would mean is that 300 minutes would be 5 hours. So if we multiply 60 by 5, we'll get to 300. And then 315 minutes is going to be 5 hours and 15 minutes. So if the bells rang together at 9 a.m, 5 hours and 15 minutes later will take us up to 2:15 p.m.